Hello everyone. Today Robometrics will present to you the DH parameter of Puma560 and how to go about and write it in Peter Corke Toolbox in Matlab. So what we'll initially do is first write the value, the main command, that is the link. Once we write that, we get this 4 values. So you can see that there are values of theta, d, a, alpha and 0, that is the offset, which we'll not consider. So theta equals to q, what does it mean? That is our joint angle. Then we have d equals to 0, that is our value of link offset. Then we have a equals to 0, that is our value of link length. And finally we have alpha equals to 0, that is our twist angle. So we just have to feed in all the values according to these 4 criterias. So again, now I'll start doing that. We initially write the variable L1. So that is the first link which we have, and I'll feed in the DH parameter. How will we feed in the DH parameter is according to this 4 criteria. That is, first it goes Q, then D, then A, then alpha. So let's start writing. So the first value of Q, we have Q equals to A1 over here. What A1 means is 0. That is, if it was A1 plus something, that something will come in. That is A1 plus 90. So 90 would have been there. Now D equals to what? Again we have D equals to 0 here. Then we have A, which is equal to 0. And then finally we have alpha, which is pi by 2. We'll leave in the offset value as 0 since we're not changing anything in it. Okay, we have defined our link 1. Now I'll just copy paste and write the second link. We have A2 plus 0, that is, we'll write 0 over here. Then we have 0 again, and then we have 0.4318. And then finally alpha equals to 0. Again I'll do the same and copy paste it and write the third link, which is 0. Then we have D value equals to 0.150. Then we have 0.0203. And then we have finally minus pi by 2. Okay. Once we are done with that, we'll update the last rows, that is 0.4318, then pi by 2 again and 0. Then L5, which everything is 0 except that minus pi by 2. Then finally L6, and it's same, but the pi by 2 is 0 over here. Yeah. So once we have written all the 6 links from the DH parameter, we just need to write the final link, that is the R. We'll just sum up everything together, that meaning that is one robot. So we name it as Puma, and how we connect it is by writing serial link, and in that we'll pass in L, that is our variable for L1, L2, L3, L4 and so on. Once we do that, we'll do Puma dot plot, that is, I'll plot whatever we have given the DH parameter and then plot it with Q1, Q2, Q3, Q4, that is our A1, A2, A3, A4, and we'll consider them as 0, that is, they are at the 0 offset and 0, that all angles are 0 right now. Either we can do like this and define Q1 equals to 0, or we can simply pass in all the values at 0. Let us do zeros over it right now. And once we do that, we'll do Puma.plot. And I run the. So this is what the manipulator, that is Puma560, looks like when we feed in our own DH parameter. That is, it's not something which is there in Matlab already. But I'll just take a screenshot of it. Okay, so that, once we feed in the original Puma 560, which the Matlab has, and we'll compare if we got the correct one or not. So to do that, we'll just initiate the Puma 560 by writing MDL underscore Puma 560. After that, we'll do, see, we got Puma P560 in our workspace, right? Then we'll do .teach, and what this does is you can change the values of the angles. So this Q1, Q2, Q3 are initially at 0, but if you see, it's 0, and the model which we got, it looks exactly the same at 0 angles. So we can say that the Matlab was able to plot with our own DH parameter the correct Puma 560. Okay, and I hope this was good for this video, and if you have any more doubts, let me know. Thank you. Robometrics.